Hello everybody, thanks for joining me for a session with the Scottish Seabird Centre. My name is Fran, I'm the Education Officer, and I'll be with you for the first part of your session today. Before we start the session, please make sure that you have some paper and a pen or pencil available. If you don't have these already, please pause me now. There are going to be some ongoing tasks throughout the session as I'm talking to you today. The first is, have a go and write down the total number of different seabird species mentioned. The second is to record the diet and breeding location of one of the seabirds we talk about today. See if you can note down some of the distinctive features of the breeding site and why that seabird may choose to nest there. The Scottish Seabird Centre is a conservation and education charity in the beautiful coastal town of North Berwick, about 20 minutes east of Edinburgh. A chain of islands sits just off the coast of North Berwick in the Firth of Forth. The iconic Bass Rock sits just 5 kilometres northeast of North Berwick. At the peak of the season, this steep-sided volcanic rock is home to over 150,000 gannets, making it the world's largest colony of northern gannets. Northern gannets are one of Britain's largest seabirds. The northern gannet is bright white, with distinctive black wingtips and a yellow head. When flying, they alternate between flapping and gliding, swooping low over the water. They feed by circling high above the waves before folding their wings back and diving into the water head first at speeds of up to 60 miles per hour. They are in search of mackerel and herring. Scotland is home to around 60% of Europe's gannets, and from February onwards they return to key breeding sites around the coast, including the Bass Rock. These seabirds favour coastal cliffs and remote islands. In addition to the gannets, the lower ledges of the Bass are home to shags, guillemots and razorbills, with seals hauling up on the rocks below. Onto the small rocky island of Fidra, which lies about 3 miles west of the Scottish Seabird Centre. With its grassy slopes and cliffs, Fidra is home to significant populations of shags, guillemots, razorbills, gulls, puffins and nesting fulmars. Northern fulmars look similar to some gull species, with a white head and underside, grey wings and a dirty yellow beak. However, their thick neck, dark eyes and straight, stiff wings set them apart. They have a tube-like ridge visible at the top of their beak. They defend their cliff-face nests from intruders by spitting out a foul-smelling oil. When on the move, they generally fly low over the water with shallow wing beats, although they will glide higher around coastal breeding sites, riding the updrafts. Fulmars feed in large flocks out in open water, catching small fish such as sand eels and crustaceans. They're a common sight in the Firth of Forth. They breed on the rocky cliff faces and can often be found nesting amongst other seabird species. They are always offshore, feeding in flocks or rafting in rafts, except when they're breeding. Craigleith is the next island in the chain. With its grassy slopes and rocky cliffs, it is home to a rich variety of seabirds, such as cormorants and kittiwakes, and its particular hotspot for puffins. Puffins are sometimes known as the clown of the sea. The Atlantic puffin is an iconic species, easily identifiable in the summer months by its black and white feathers, brightly coloured beak and orange legs. With fast wing beats and distinctive profile, this small seabird can often be spotted flying low over the waves. Puffins feed by diving up to 60 metres from the surface of the water in search of small fish such as herring, hake and sand eels. Puffins can be seen at a number of locations around the Scottish coast. In the breeding season, they gather at nesting sites, puffineries, which are usually burrows located on grassy cliff tops. Puffins then spend the winter months out at sea. The islands Fidra, Lamb, Craigleith and the Bass Rock are designated sites of special scientific interest and are part of a larger special protection area under EU legislation due to their internationally important breeding seabird populations. During May to August, there are up to 500,000 seabirds present on the Forth Islands. So why are seabirds important? Well, there are many reasons, one being the important place they hold in the marine food web. Seabirds get energy by eating fish. Fish eat plankton, which are microscopic plants and animals. The movement of energy from one living thing to another in this way is called a food chain. When all the food chains in an ecosystem are joined up together, they form a food web. All organisms in a food web depend upon each other. If the number of one organism increases or decreases dramatically, this has consequences for others. For example, puffins eat sand eels, but as the water warms, due to climate change, colder water species such as sand eels are moving northwards and deeper in search of cooler water. Many seabirds therefore have to travel further to find their prey food, and they can't provide enough to feed their chicks. Pause now to discuss, what would happen to this ocean food web if all the sand eels disappeared? Now, the seabirds leave regurgitated fish and plenty of poo on the islands. This can be washed off the rocks by the sea, which provides fertile waters, which in turn support plankton. Now, phytoplankton, which are microscopic plants, live on the ocean's surface. They use sunlight to make food, taking up carbon dioxide from the atmosphere and releasing oxygen. Did you know that our seas absorb a lot of our carbon dioxide emissions? The carbon dioxide is consumed during this process of photosynthesis. When the plankton die, they are eaten by other marine creatures, such as zooplankton. Seabirds are really good indicators of the health of our seas, and by studying them, we can learn more about how healthy our oceans are. Scotland's marine environment is internationally important for seabirds. There are 5 million breeding seabirds in Scotland, which is 70% of the UK's total breeding seabird population. I'd like you to pause now to discuss in groups what was the most surprising about what we've just learned. When we come back, we'll be hearing from our Conservation Officer, Emily.
So hopefully now you understand a bit more about why seabirds are so important for marine ecosystems and why Scotland is so important for seabirds. I'm Emily, I'm the Conservation Officer at the Scottish Seabird Centre, so it's my job to work with lots of other brilliant groups and volunteers to look after seabird habitats out on islands like Bass Rock and Craigleith. Now I'm going to talk a bit about threats to seabirds, so that's factors that have a negative impact on seabird populations. This of course includes climate change, which is an overarching threat not just for seabirds but for people and nature around the world. But before we dive into that, I thought we could chat a bit about how we, as conservationists or scientists, work out what is going on with seabirds. Now, they are not the easiest animals to keep an eye on because lots of them spend the winter way out at sea, or they might migrate to different places around the world. And even in breeding season, actually, many seabirds prefer to nest in remote places, so like tiny islands or on steep cliff faces. Now, this can make access for researchers very difficult indeed. So keeping track of how many seabirds there are, as well as things like where they breed, where they feed, what they feed on, what their movements are during the winter months, all of these are really important bits of information if we want to effectively protect them. And so we can build up a better picture of all of these things, all sorts of research and monitoring is carried out. And these studies guide all of our work as conservationists when managing habitats. They also guide us when we're promoting changes in approach or behaviour to the government or to businesses or to the general public as well. Now, this research might use very advanced tracking technology, so perhaps things like tiny geotags that are attached to birds to see where they go. It might involve more traditional methods like bird ringing, so very lightweight tiny rings can be added to birds' legs to allow us to track them. It might involve taking a closer look at individual birds, maybe to find out what they've been eating. It might involve monitoring nesting sites. Basically, if there are important questions to be answered about seabirds, scientists out there somewhere will probably be trying to answer it using one approach or another. Now, one absolutely essential bit of research which is carried out here in the Firth of Forth every year by a brilliant group of volunteers called the Forth Seabird Group are breeding seabird counts. Now these are exactly what they sound like. They're counts of seabirds breeding out on the islands and around the coastline. Now these counts allow us to compare how seabird numbers are changing over time, both locally, so here on the islands in the Firth of Forth for example, but also on a national and on an international scale too. Now counting seabirds might sound fairly easy, but it's not just the remoteness of the seabird colonies that make keeping track of the birds challenging. Now, as Fran mentioned when she chatted about Bass Rock, sometimes seabirds breed in huge numbers, in massive colonies, and this makes estimating numbers pretty challenging. But you do not have to take my word for it. I'm going to give you a wee taster of what's involved and you can try your hand at surveying for yourself. So to keep things simple, I'm just going to ask you to count individual birds. So that's rather than like activeness or anything more complicated like that. So the aim of the game is to work out how many birds are in each picture, and you can pause the video for around 30 seconds for each image to work out your answer. So here is the first one. Okay, so not too tricky, right? Hopefully you got something close to 16. And a little tip, I always think it's easier if you count the heads of the birds, because there's lots of wings and legs and general feathers going on otherwise. So we're gonna step things up a bit, because I feel like that was a wee bit easy. So here's a second image for you to have a go at. So I would say that one is definitely trickier. Hopefully you got something like around 100. I counted about 98. But you can get a feel for the fact that as the number of birds increases, of course it gets more difficult to count them accurately. It's also worth remembering that lots of surveys are carried out without the help of a camera. So what you're looking at is a cliff with lots of birds on it, or a rock face with lots of birds on it. And this is changing constantly as the birds move around. And this means that counting very quickly is absolutely key. Now, one way you can do this is to split the birds that you can see into sections, so like this. This way you should be able to count the birds in one section, and I always try and choose the section with an average number of birds in it, so that's not the most birds or the least. Now for this image I went for this section and I counted around 34. You would then multiply this by the number of sections you have, which in this case is 3, and this would give us a total of 102, which is close enough to the true total. Okay, so now here's one last image, just to give you a feel for the scale of the challenge for some seabird colonies. Now you can pause the video again here and take your best guess at how many birds are in this image. Brilliant. Now I will be very surprised and impressed if you could make much of that at all. So to try and count these guys, I would again try and work it out by splitting the group into sections and looking at a smaller proportion of the larger view. So remember, we want to try and count a square which we feel like is an average, so that's not the most crowded square but also not the least crowded either. So I counted this one and I got 146 birds, meaning that my overall total for all 12 squares would be around 1,750. So remember, this is just to give you an idea of what challenges surveying seabirds can bring in reality. Lots of different techniques and methods are used by researchers to try and ensure that the counts are accurate as possible. So there's your wee taster of bird surveying. Not as easy as you might think at all, but absolutely essential for seabird conservation. Now, the results of surveys like these ones, along with all of the other research I mentioned earlier, give us information about the threats that seabirds face, amongst other things. So here I would like you to pause the video for around 2 minutes, 3 minutes, and note down any threats that you think might impact seabirds around Scotland. That is brilliant, so hopefully you had a few ideas. Some of the main threats that jump into my mind include things like pollution, so that's everything from plastic to noise to chemicals. Pollution can include all sorts of things. Overfishing, so that's kind of exactly what it says on the tin. For some species we're taking far too many, we're not fishing with sustainability in mind. Perhaps things like bycatch, so that's the accidental capture of seabirds in fishing gear. So that's not gear that's been put out for seabirds specifically, it's been put out to collect the fish that we eat, but unfortunately perhaps a seabird has been captured by accident, and this happens for other species like whales and dolphins too. There's things like invasive non-native species. Now that sounds complicated, but it's actually just plants or animals that end up in places where they shouldn't be, and when they arrive they cause all sorts of big problems for the seabirds breeding there. And then of course we've got climate change. Now, to talk about how climate change is impacting seabirds, we do first have to chat about how it's impacting the marine environment more generally. So to access the food they need, seabirds rely on all of those food chains Fran talked about earlier, having a good time, doing their thing under the surface of the water. Because of this, we call seabirds indicator species. Now this is because how seabirds are getting on above the waves may indicate how well or badly things are going below the waves. Now, you might already know that climate change is having a big impact on our oceans, and this is happening in a lot of different ways. So for example, sea temperatures are rising. In the North Sea, the temperature has risen by 1 degree C in just 25 years, and warming waters mean that species are on the move. So basically, animals and plants that need colder waters are having to move further north to find them, and creatures that do well in warm waters or warmer waters are arriving to hang out around our coasts. Now this might sound cool, especially if you go out snorkeling or paddleboarding or wild swimming like I do, because we might get to see some new animals when we're out and about hanging around on the coast. But this is setting those food chains that Fran mentioned earlier way off track, because things are changing too quickly for a lot of species that live in the sea around the UK to keep up. Now the chemistry of the oceans is changing too, and one example of this is ocean acidification. Now this means that lots of shelled animals and organisms aren't having such a good time at all, because they are unable to maintain their shells in the same way in an, or albeit very slightly, more acidic environment. Now again, this impacts on the wider ocean food chains. We're also seeing more extreme weather events, which is making survival and productivity, so productivity is successfully reproducing and raising their young to adulthood. So it's making those two things very difficult for a lot of our wildlife. And that's bearing in mind that these species already live in very challenging conditions. So even before you throw in lots of extreme weather into the mix. Now, although oceans are in a lot of trouble because of climate change, and because of all of the other threats and pressures we chatted about earlier, they also hold bags of potential for starting to tackle climate crisis if we restore and protect marine habitats properly. Now, when we talk about nature helping to tackle climate change, we talk a lot about planting trees. Now, this is very important. I love trees. Hopefully a lot of you are big fans of trees as well. But sometimes people forget that a huge amount of carbon can be captured and stored by the world's oceans and coastal ecosystems if we look after them properly. However, restoring nature will only go some way to tackling climate change. We also have to dramatically reduce our emissions too. And this is something that Charlotte is going to chat a wee bit more about in the next section of the session.
Hello, I hope you've all been enjoying the session so far. I'm Charlotte, Marine Engagement Officer at the Scottish Seabird Centre. My job is to think of new, exciting ways to raise awareness of the marine environment and inspire people to protect it. As you've heard, the marine environment is at risk from climate change, but our seas also provide an opportunity to combat climate change through marine renewable energy. In this section, I'll be providing an overview of this type of energy, what it is, why we need it, and what it means for Scotland's seabirds. So, what are renewable energy sources? Well, simply put, they are sources of energy that quickly replenish themselves and can be used again and again. For this reason, they are sometimes called infinite energy resources. These differ to non-renewable fossil fuels such as coal, oil and gas, which once burnt to make energy aren't replenished for millions of years and will one day run out. They also emit large amounts of greenhouse gases into the atmosphere, leading to climate change. All in all, fossil fuels are an unsustainable source of energy. Thankfully though, there's a push to replace fossil fuels with sustainable renewable sources. Renewable electricity now represents around 43% of the UK's total energy generation, and in January 2020, it actually exceeded fossil fuel production for the first time. So, renewables are an important weapon in the fight against climate change, but how well do you know your renewables? In a moment, I'm going to put up a picture that contains clues of 8 sources of renewable energy. Your task is to use the clues to name all of the sources. Can you get all 8? Here comes the picture. Pause the video once it's up to give you plenty of time to have a go. That's your time up. Let's see how you got on. Sources such as solar, wind and wave are possibly the easiest ones to get. Trickier ones are tidal, energy from the rising and falling tides, geothermal, energy harnessed from heat emitted from the earth, hydrological, energy harnessed from the movement of water through rivers, lakes and dams, wood, energy from burning trees, and biomass, burning leftover bits of crops. Note that the last 2, wood and biomass, are only considered renewable if the trees or crops are replanted. But well done for identifying those sources, especially if you got all 8, very impressive. We're now going to look closely at the sources captured at sea, the marine renewable sources. With over 60% of the UK's total sea area and plenty of wild windy weather, Scotland holds a huge amount of potential for marine renewable energy sources. There are 3 sources of marine renewable energy. These are wave, tidal and offshore wind. First up, we have wave energy. Waves are formed by winds blowing over the surface of the sea. The size of waves depends on the strength of the wind, the depth of the sea and the currents under the water. In the UK, the biggest waves occur in areas where strong winds have travelled over long distances. One place on the west coast of Scotland, called Billy Crew, has waves that can be up to 18 metres high. That's the same height as 4 double-decker buses stacked on top of one another. So, waves contain lots of energy, but how is energy collected from these waves? Well, the moving water in waves carries kinetic energy, which can be captured and converted into electricity by special devices called wave energy converters. Different designs are being developed around the world. Some sit on the surface, like the device in this photo, whilst others are suspended below the water. Wave energy holds lots of promise, but developments are still at a relatively early stage, with lots of different technologies being tested. Next up, we have tidal energy. Tides are the rising and falling of the sea, usually twice a day. Tides are caused by the gravitational pull of the moon and the sun on the world's oceans. In most places, the change of the tide is gradual, and you need help of a time-lapse camera to see the change occurring. However, in some places, the tide actually comes in quicker than a person can run, making some areas quite treacherous in certain conditions. When tides switch direction, they create a current of water called a tidal stream. Tides that are funneled into narrow areas, for example between islands or into estuaries, create stronger tidal streams than in other places. For example, water flowing between islands of the Orkney can reach 10 miles an hour. That's pretty fast for flowing water. Tidal stream technologies capture the kinetic energy carried in these currents and convert it into electricity. There are lots of different designs, but generally they work like underwater wind turbines. Like wave energy, tidal energy is still developing, but there are now commercial tidal sites around the world that create electricity for our everyday use. In fact, the Pentland Firth off Scotland was the first ever commercial tidal site. And finally, offshore wind. Wind is the movement of air across the planet. Winds occur when air rushes from an area of high pressure to low pressure, and offshore wind is simply wind that occurs over the sea. So wind turbines, or wind energy converters, are devices that convert that kinetic energy in the wind into electricity. Wind simply turns the blade, which spins a generator, which creates the electricity. When lots of turbines are used in one place, it's called a wind farm. Wind farms constructed at sea are known as offshore wind farms. Now, out in the ocean, the only limitation on size is engineering. The largest wind turbine in operation stands at a whopping 260 metres tall and has turbine blades over 100 metres in length. That's the same length as a football field. The size of this turbine means that a single rotation generates enough electricity to power an average home for more than 2 days. As you can imagine, assembling a huge wind turbine like this in the sea is a big task. There are different ways turbines can be anchored in the sea. Some are built on foundations on the seafloor, whilst others float on the water. Turbines built on foundations are required to be pile-driven into the seafloor, whilst floating turbines require anchoring to seafloor using cables. Electricity from these turbines are then transported by cables which are placed at the bottom of the sea. This can either be done by burying them in the sediment or laying them on top. Now, in the UK, power that comes from wind turbines is actually growing. It now makes up nearly a quarter of the green energy production, and more offshore wind farms are being built and planned. One that is being built particularly close to us here in the Firth of Forth is the NNG development. Its full name, Nach de Goide, means strength of the winds in Gaelic. Once finished, it will consist of 54 turbines that will produce enough electricity to power the whole of Edinburgh. But building a large wind farm in the environment may have bad knock-on effects on the wildlife that lives there. What about all our lovely seabirds in the Firth, for example? Might this development disturb them in any way? So, to answer this question, I'd like you to imagine you're a gannet living on Bass Rock. Imagine you've just set off to hunt for some fish when you come across a huge wind farm. What happens? What I'd like you to do is pause the video in a second for a couple of minutes to discuss and note down a few ideas of how gannets might be badly affected by wind farms. Okay, that's time up. Let's see what's in store for this group of gannets. So there are lots of different things that could impact seabirds, but 3 things that stand out as being potentially the most severe is, sadly, death or injury from colliding with turbine blades. Different species are more susceptible to this than others as they fly at different heights, so some will meet this fate more than others. Secondly, birds are also forced to avoid areas with turbines, meaning they may have to travel further and use up more energy during the migrations or to find food. This is called a barrier effect. And lastly, birds can also be disturbed by the construction and operation of the turbines. This noise can sometimes cause stress and also have an impact on their feeding and breeding behaviours. So, the Scottish Seabird Centre is therefore definitely concerned by the impact the NNG wind farm will have on the local seabird populations, and we have been watching the plans closely and talking to developers. Thankfully, new developments such as NNG are required by law to conduct surveys to assess the impact on the environment. Things that are researched include the location of seabirds, the type of birds that are there, and how big their populations are. These findings then help developers avoid the most sensitive areas for seabirds and help make the wind farm in a more seabird-friendly way. This can involve avoiding seabird hotspots, reducing the number of turbines, and even the height of turbine blades from the sea. However, even with the regulations and the surveying, getting the balance between marine renewable energy and protecting nature is challenging. Our position at the Seabird Centre is therefore as follows. We value the contribution that marine renewable developments can make in combating the climate crisis. Technologies are, however, still relatively new. They are still being developed and tested, and we still don't fully understand their impact on the environment. So, in order to prevent significant damage to our seas and wildlife, we believe we need the right type of technology at the right scale and in the right place. At the end of the day, we must remember that as well as a climate crisis, we are also in the middle of a nature crisis, with nearly half of Scotland's nature in decline. And that's what we're all about here at the Seabird Centre. We're here to speak up for the marine environment and protect it however we can. So that's the end of the session with us. I hope you learned something new today and are inspired to find out more to do your bit to help our seas. Should you have any questions, you can contact us using the details provided, or more information on topics covered in this workshop, plus information on marine science careers, you can check out our dive-in packs available on our website. Thank you and goodbye.